Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we continue with our topic of discussion. The topic is acids, bases, and indicators, topic in Form 1 chemistry. So at this point, we are going to discuss commercial indicators. And this is in addition to what we discussed the last time, whereby we discussed the extraction of indicators from plant extracts. And we saw the disadvantages of those indicators that are obtained from plant extracts, and that is now why there is need for commercial indicators. So commercial indicators give consistent results. They can be stored for a long time for future use, and so on and so forth. And we'll have various examples. We have, for example, an indicator that is called litmus. Litmus can either be in form of a solution called litmus solution. It can also be in form of a paper called litmus paper. We have other commercial indicators such as methyl orange. There is phenolphthalein. There is screened methyl orange. There are many. There are bromothymol blue. So there are several. But of course, we'll only mention the common ones, the ones that are commonly used in our laboratories. So we can say that common commercial indicators include, we have litmus, we have methyl orange, there is also screened methyl orange, there is phenolphthalein, there is a bromothymol blue. So all those, they are commercial indicators, but we'll mainly mention the litmus and the methyl orange and phenolphthalein because those are the common ones that we actually use. So we can first of all say that these indicators give consistent results. So they cannot give you results today and then tomorrow they give you results that are different. So they'll have to be consistent. That's why they are more recommended as compared to the simple ones that are obtained from plants. So these ones are basically the ones that we use. So they give consistent results and can be stored for future use. So at this point, we'll have a table showing the effects of commercial indicators on different solutions. Effects of commercial indicators on different solutions. So we'll put these as a table. So we'll have a solution being tested in the first column. Then here we can use litmus paper is one of the indicators, or we can still use the litmus solution. They just give the same results. Then we have methyl orange indicator. and then we have phenolphthalein indicator. So for example, we can take lemon juice. If you test it with litmus paper, the color turns red. So you can mention somewhere here that this is the color obtained using either of those indicators, using litmus paper. So when using a litmus paper, the color obtained is red with lemon juice. When you use methyl orange, the color here is pink. When you use phenolphthalein, it's colorless. So you can see that different indicators give us different colors with the same solution. On the other hand, if we use something like soap solution, with the litmus, the color will be blue. With methyl orange, the color will be yellow. And with phenolphthalein, the color will be pink. So you can see all of them are giving us different colors. We take an example of hydrochloric acid. In litmus, it will be red. In methyl orange will be pink. And in phenolphthalein will be colorless. So we can observe something here, that hydrochloric acid is behaving the same way as lemon juice in all the indicators. And that is an indication that lemon juice and hydrochloric acid are acidic. They are acidic. But soap solution is not acidic. That's why it's giving us different colors. If you take something like caustic soda solution, so this one will behave like the soap solution. Blue with litmus, yellow with methyl orange, and pink with phenolphthalein. So 2 and 3, they have similar properties. That means caustic soda solution and soap solution, they are bases. They are bases. That's why they are giving similar colors with the various indicators. If we take an example of distilled water, the litmus is purple, the methyl orange is orange. That means the color remains orange. Litmus, the color remains purple. Phenolphthalein, the color is colorless, it remains. So for distilled water, this is neutral. It's neither acidic nor basic. It's not behaving like the others. That shows that it has its own properties that are different. So the list can be long. We can have as many chemicals as we want. But something that is worth mentioning, we can say that from the above table, we can say A, lemon juice, hydrochloric acid, we can still use sulfuric acid, all give similar, they give similar colors with different indicators. They give similar colors with different indicators. They are all acidic. All of them are acidic. That's why they are giving the same colors. Lemon juice, hydrochloric acid, even if we were to use sulfuric acid, it will give us all those colors. So that's an indication that all acidic substances will behave like that. On the other hand, we can say that soap solution, caustic soda solution, we can have potassium hydroxide, sodium hydroxide, and others not on the list. They also give similar colors with the different indicators. With the different indicators above. They are all basic. So they are all bases. So they are bases because they have their own color that they are giving us that is different from those that are acidic. Remember we said that the work of the indicators is to tell us, is this an acid or is this a base? If it is an acid, it gives you a certain color. If it is a base, it gives you a different color. Then we have distilled water that is giving us a completely different color from the others. So here distilled water, we are saying that it is neutral because the litmus remains purple. It doesn't turn red or blue. The methyl orange remains orange. Phenolphthalein remains colorless. So that is an indication that they are neutral. So you can say that distilled water and common salt solution even sugar solution can also use it there. They do not change the color of indicators. They do not change the color of indicators above, i.e. they are neutral. They are neutral. And neutral means neither acidic, they are neither acidic nor basic. So they are not acids and they are not bases. Distilled water, common salt, sugar solution, those ones have no effect on the indicators. But you can see that lemon juice, hydrochloric acid, sulfuric acid, those ones are acidic. They are giving you similar colors. If it is using litmus, all of them are red. If it is using methyl orange, all of them are pink. If it is using phenolphthalein, they are colorless. So if the behavior is the same, then it means that they have similar properties or they have the same properties. So we can summarize that again and say that we can have the indicator, then we can have color in acid, base, and neutral solution. So for example, we can start with the litmus. In acid, it is red. In base, it is blue. In neutral, it's purple. So we are summarizing this from here. If it is methyl orange, in acid, it is pink. In base, it is yellow, as we can see there. And then in neutral, it's orange. And then finally, phenolphthalein. As another indicator. In acid, it is colorless. In base, it is pink. In neutral, it's also colorless. So this is the conclusion that we've got from the first table. We have an indicator, and then we have the various colors that it gives us. If, for example, the solution is acidic, if it is basic, and if it is neutral. So color in acid, litmus is red. In base, it is blue. In neutral, it's purple. Methyl orange, in an acid, it is pink. In a base, it is yellow. In a neutral solution, orange. Phenolphthalein, if you put it into an acid, it is colorless. In a base, pink. In a neutral solution, colorless. So that tells us that indicators give us different colors in an acid and different colors in a base. So you can have an assignment. So the first question, complete the table below, the indicator, the color it gives in an acid, the color it gives in a base, and in a neutral solution. So starting with phenolphthalein, methyl orange, litmus paper in each. And then question number 2, why is it advisable to use commercial indicators in the laboratory? Why is it advisable to use commercial indicators in the laboratory? So we'll stop there. Until next time, goodbye.